Hello, I'm very pleased to meet you all. Do you know how many calculations a graphics processor, also known as a GPU, needs to perform per second when you're gaming? I don't know either, but let's take a few examples to help you visualize. Imagine you're seeing the gameplay of the pixelated graphics from Super Mario 64, a game released by Nintendo in 1996. To play this game, graphics cards from 28 years ago had to process around 100 million calculations per second. To play Minecraft in 2011, the graphics card needed to handle around 100 billion calculations per second. While to smoothly play Cyberpunk 2077, you need a graphics card that can perform around 36 trillion calculations per second. These are numbers beyond imagination. To put it in perspective, our Milky Way galaxy has about 100 billion stars. Let's take another example. If every person on Earth stopped what they were doing to perform a calculation, we would need about 4,400 Earths similar to ours to generate computing power equivalent to 36 trillion calculations per second for you to play Cyberpunk smoothly. It's hard to believe that a graphics card you can hold with one hand can perform such a staggering amount of work. But why do you need a graphics card to watch videos or play games when every computer has a powerful processing chip called a CPU? Why not use the CPU for gaming? If one CPU isn't enough, why not use 2 or 3? Why create a chip specifically for gaming and call it a GPU? What's the difference between a CPU and a GPU? Or is it just a way to rip off consumers? The answer will be in this video. A typical consumer CPU usually has a maximum of around 24 cores. For example, the Intel Core i9-140K. I know you can Google for CPUs with more cores, but let's talk about the CPUs that average users would buy. In contrast, a common graphics card, like the NVIDIA GeForce RTX 4090, has 16,384 cores in its GPU. You didn't mishear me, and I didn't mistype any numbers. This is one of the fundamental differences between a CPU and a GPU. What we call a graphics card or GPU is actually a complex device that includes a graphics processing unit, circuit board, memory, cooling system, and various ports. 16,000 is significantly more than 24. So you might think that GPUs are much more powerful than CPUs, and that's true, but it's a bit more complicated than that. Perhaps you've seen a video from about 16 years ago where two guys, Adam and JY from the show Mythbusters, built two systems to highlight the differences between a CPU and a GPU. The CPU was likened to a single-barrel paintball gun that fires one paintball at a time to color a canvas, taking a long time to create a simple image. Then the GPU appears, likened to a paintball gun with 1,100 barrels that can cover the Mona Lisa in the blink of an eye. You even need slow-motion footage to see what just happened. This illustration isn't inaccurate, but it seems to diminish the CPU's capabilities drastically. It's like catching a shark climbing a tree and saying it's inferior to a monkey by 1,000 times. I will clarify this later. In the meantime, think of the GPU as a gigantic container ship and the CPU as a Boeing 747 airplane. The ship can carry a lot more cargo, but the airplane is much faster. This is a trade-off between workload capacity and speed of completion. The GPU has a lot of cores. It's like a ship that can carry many containers, but each of its cores is just like a simple handheld computer. It's much smaller, simpler, and physiologically weaker than a CPU core, as shown by the speed of the airplane being many times faster than the ship.